Hello everyone, this is me, Parthi Goyal. Today we will be solving a Leetcode problem of the day. So let's look into the problem. Okay, so the problem name is max chunks to make sorted. Okay, so you are given an array of length n that represent a permutation of the integer in the range 0 to n minus 1. We split AR into some number of chunks and we will sort each chunk. Okay, and then we will concatenate them and the result should equals to the sorted array. Okay, return the largest number of chunks we can make to sort the array. Okay, so let's take this example. Okay, so for this whole array is a single chunk. Okay, let's take this one. Okay, for this, okay, this is a single chunk, and after that this is also a single chunk. Okay, then okay, and we can individually divide them. Okay, so it will be 1 comma 0, then 2 3 4, and after that it will become 0 1 2 3 4. So this is our answer 4. Okay, so what we are doing is okay, if you observe that for a single range, okay, like this is the range, so we will be taking the maximum element in that particular range. Okay, and after that we will check in the right hand side that that max, like the current maximum is smaller than the minimum element in the right side. So what does it mean is like we are having an array of this okay, so currently we are at index 0. Okay, so the max element will be 1. Okay, and minimum element in the right hand side is 0. So if we check the 1 is smaller than the minimum element of right hand side, this is not a true, so we can't take this chunk. After that the maximum will be become 1 only, because the maximum of 1 and 0 is 1, and minimum of right hand side, minimum of 2 3 and 4, which will be 2. So here the maximum, like the current maximum is minimum than the minimum of right hand side. So at index number 1 we got our first chunk. After that the maximum will be becoming 2 and minimum will be 3. So this condition also satisfies, like the current maximum is smaller than the minimum of right hand side. So this is one more chunk. After that maximum will become 3, minimum will be 4. Okay, so this will be another chunk. So this is how we will be generating the answer. So let's look into the code, and after that we will try to optimize that. Because the constraint is very smaller, we will try to do some brute force code first. Okay, first restrict length of the array. I to n minus 1, and maximum is array of j if maximum is smaller than minimum of array of j plus 1 to end. Then answer we will be taking as 1. 1 plus solve of j plus 1 return answer. Here we can return solve of 0. Okay, so we have taken a function. Okay, so here what we are doing is we are calling from the index 0. After that we are just checking the maximum element. If the maximum is smaller than the minimum of right hand side, then we are just increasing the count. Let's check it out. Okay, that is working, but it is working because of the constraint are very smaller. Let's try to optimize it. Okay, so what we are doing is we are just calling the function from the 0, then that. Okay, we can solve it without function as well, I think. Let's do like this. And okay, okay, if we do something like this, then also it should work, I think. Okay, it is, we haven't considered a max. Okay, that is also working. So here what we are doing is we are, okay, what we can do is we can take one more prefix array, and that will do the thing for getting the minimum. Okay, let's take one other prefix. For in ARR, MN of it is prefix of that will also work, I think. Okay, okay, we have considered I there. That is the thing. Okay. I think we can reduce it further as well. Why it is needed, that is also fine. Okay, for I if this is I think okay, it is okay. Can't we reduce it further? Okay. Okay, the answer, okay, the array is given 0 to n minus 1 only. Array is 0 to n minus 1, then okay. If it is 0 to n minus 1, then do we need to do that? Okay. Okay, if the element are not no in a permutation manner, like we are having element which is like 1, 2 and 100 and 200 or something, it is like a node in the range of 0 to n minus 1, then that code is the most optimal one, which I feel. But if we are having an element in the range of 0 to n minus 1, like we have given a permutation, then I think we can reduce the space complexity as well, because what I'm thinking is like let's suppose we are having current maximum, okay, and our current maximum is pointing to its particular index, okay. So what I'm saying is like as I equals to 0, our current maximum is 1, okay. At I equals to 1, our current maximum will become 1, okay. So now I equals to 1 and current maximum is also 1, so that means in this in the two indexes, we are getting a current maximum as 1, okay. So we are having two elements on which the current maximum is 1, so that means it contains the smaller element which is 0 and also the maximum one, okay. So here we can just increase our answer. So for that I feel this is a good thing. Okay. That is mx equals to I. Okay, this is only working because we have given a permutation. If we are not having a permutation, then the previous code will be working absolutely fine. So yeah, that's it for that particular problem. If you have any doubt in this particular problem, please let me know in the comment section.